Welcome to Beyond Earth. What if I told you the hottest planet in our solar system isn't the closest to the Sun? It's a world of extreme heat, crushing pressure, and clouds made of acid. This is Venus. At first glance, it doesn't make sense. Mercury orbits much closer to the Sun than Venus. During the day, Mercury's surface gets incredibly hot, but at night, it freezes. That's because Mercury has almost no atmosphere to trap heat. Venus, on the other hand, is completely different. Its atmosphere is incredibly thick, so dense that it acts like a blanket wrapped around the entire planet. Instead of heat escaping back into space, it gets trapped, locked in, building over time, until the entire planet becomes an oven. The result is a surface temperature of about 465 degrees Celsius, hot enough to melt lead, hot enough to warp metal, hot enough to destroy anything we've ever sent there. And the most shocking part? That temperature stays almost exactly the same everywhere, day or night, equator or poles. Venus doesn't cool down. This extreme heat is caused by something known as the runaway greenhouse effect. Venus's atmosphere is made up of more than 96% carbon dioxide. On Earth, greenhouse gases like CO2 help keep our planet warm. Without them, Earth would be a frozen world. But on Venus, that same process went completely out of control. Sunlight passes through the thick clouds and heats the surface. But once that heat tries to escape, it can't. The dense atmosphere traps it, again and again, layer after layer. Each cycle adds more heat. Over millions of years, the temperature continued to rise until it reached a point where the planet could no longer cool itself. And once that happened, there was no going back. Venus became locked in a permanent state of extreme heat. But Venus doesn't just burn, it crushes. The atmospheric pressure at the surface is about 90 times greater than Earth's. To put that into perspective, it's like being nearly a kilometer underwater. Except instead of water, it's thick, superheated gas pressing down from all directions. Any spacecraft that lands on Venus has to survive both heat and pressure, and most don't last long. The Soviet Venera missions were the first to reach the surface. Their landers were built to withstand extreme conditions. Even so, the longest-lasting one survived just over 2 hours. After that, the systems failed. Electronics overheated. Structures weakened, and the planet claimed another machine. From space, Venus looks smooth and bright. Its clouds reflect sunlight, making it one of the brightest objects in the night sky. But those clouds hide something far more dangerous. They're made of sulfuric acid, thick, swirling layers that completely cover the planet. If you were descending through Venus's atmosphere, you'd pass through these clouds first, acid droplets drifting all around you, winds in the upper atmosphere moving at incredible speeds, and below that, a dense, suffocating haze. By the time you reach the surface, you wouldn't see blue skies, no stars, no clear horizon, just a dim, yellowish glow filtering through the thick atmosphere, a sky that never clears. Venus is strange in ways that go beyond its environment. It doesn't just look different, it behaves differently. Venus rotates in the opposite direction of most planets. On Venus, the sun rises in the west and sets in the east. But what's even more bizarre is how slowly it spins. One full rotation takes about 243 Earth days. That means a single day on Venus is longer than its entire year. In fact, Venus completes an orbit around the Sun in just 225 Earth days. So incredibly, a day lasts longer than a year. Time on Venus doesn't follow the rules we're used to. Hidden beneath its thick atmosphere lies a world shaped by fire. Vast plains of solidified lava stretch for thousands of kilometers. Giant shield volcanoes rise across the surface. Some of them are among the largest in the solar system. There are surprisingly few impact craters, which suggests the surface is relatively young. Scientists believe Venus may still be geologically active today. That means volcanoes could still be erupting right now, beneath the clouds. But we can't see them directly. The atmosphere is too thick, so instead, scientists use radar to map the surface, revealing a landscape that feels both familiar and completely alien. Let's imagine trying to land there. As your spacecraft approaches Venus, everything seems calm at first. Bright clouds, smooth appearance. But as you descend, things change quickly. The air becomes thicker. The temperature begins to rise. Pressure starts building. Your instruments begin to struggle. As you pass through the cloud layers, visibility drops. The light fades into a dim yellow glow. Then, the heat becomes intense. Your systems begin to fail. By the time you reach the surface, it's already too late. The temperature is high enough to melt metal. The pressure is crushing, and within minutes, everything shuts down. Venus doesn't allow visitors. Despite how hostile it is today, Venus may not have always been this way. Some scientists believe that billions of years ago, Venus could have had oceans, liquid water, possibly even conditions similar to early Earth. But as the sun grew brighter and temperatures increased, those oceans may have evaporated. Water vapor entered the atmosphere, becoming another powerful greenhouse gas. That accelerated the heating process, and eventually, it triggered the runaway greenhouse effect, transforming Venus into the extreme world we see today. Venus is a world of extremes, a planet where heat never escapes, where pressure crushes everything, and where some clouds hide a violent surface below. It may look calm and beautiful from space, but up close, it's one of the most unforgiving places in the solar system. And yet, it might also be one of the most important, because Venus shows us what can happen when a planet loses control of its climate. Thanks for watching Beyond Earth. If you enjoyed this video, please don't forget to like and subscribe. It really does help the channel grow.